Greetings to you, everyone. Rama is here from Rama Explains. In the last class, we discussed organic chemistry and hydrocarbon as introduction in organic chemistry, and we discussed the classes of functional group that are present in organic chemistry. So we mentioned aliphatic as one of the branch of hydrocarbon. So today we are going to discuss alkanes as one of the aliphatic compound present in hydrocarbon. So the aliphatic hydrocarbon, as explained in the previous class, is the straight chain of hydrocarbon, while the other is aromatic. So aliphatic hydrocarbon is a straight chain and it contains alkanes, alkane, and alkynes and other derivatives. So alkane, in our class today we are going to discuss alkanes. Alkanes are hydrocarbon that have the general formula CnH2n plus 2. So alkane contains CnH2n plus 2 general formula, where N represents 1 or 2 or 3 carbon. See, where N represents 1, 2 or 3 number of carbon. So we have the first 10 straight chain of alkanes include methane. Methane is the simplest form of alkane. So it has the molecular formula CH4, which is derived from the general formula as we have here. So let's take for example methane being the simplest of the functional group of alkane, using the general formula CnH2n plus 2. We have this formula here. The number of carbon present in methane is number 1. So substituting 1 we in position of n present in the formula as we have here, we give us, substituting 1 will give us C1H2 into bracket 1 plus 2, and calculating this we have C times 1 will give us C, H2 2 times 1 will give us 2, 2 plus 1 equal to 2 plus 2 equal to 4, and we have CH4. So this is the formula of methane, which is the simplest of the alkane group. After alkane we have methane. After methane we have ethane. So in ethane, as we have here, which is the second member of the functional group of alkanes, we have ethane. Ethane has 2 carbon, as we can see in the molecular formula here. Substituting the 2 carbon into the general formula we have as 2, we have C2H2 times 2 plus 2, which is going to give us C2H6. So, and this general formula applies to all the functional group present in alkane functional group of the aliphatic hydrocarbon. So we have propane, butane, which has 4. We have pentane that contains 5. We have hexane that contains 6 carbon. We have heptane that contains 7 carbon atom. We have octane that contains 8 carbon atom. We have nonane that contains 9 carbon atom. We have decane that contains 10 carbon atom. and the molecular and the melting point of the hydrocarbon increases down as from the simple molecular weight. As we have increase in molecular weight, the melting and boiling point increases. So in the as we have more carbon atom, or we have more mass, the boiling point increases. As we can see from here, the simplest, we have the minus 182.5 as the melting point in degrees Celsius, and we have boiling point of 161.6 minus 161.6. And as we increase in molecular weight, the melting point and boiling point also do increases. So the characteristics of alkanes. What are the characteristics of the alkanes? What do we know alkanes to possess? The essential characteristics of alkanes is that they have only single covalent bond are present in their bonds. So they did not have double bond, they did not have triple bond, they have only single covalent bond. Therefore, they contain only sigma bond. Alkanes contain only sigma bond, no pi bond. The alkanes are known as saturated hydrocarbon because they contain the maximum number of hydrogen atom that can bond with the N. The simplest alkane is with the N number 1, which is methane, as we have discussed earlier. Methane is the simplest of the alkanes, which is the natural product of anaerobic bacteria, the composition of vegetable matter underwater. Because it was first collected in marshes, methane became known as marsh gas, a rather improbable number of carbon atom present. So methane, another thing to know is that the first group of alkane group, there are gases such as the alkane, and such as the methane, the ethane, the propane, and butane. The first 4 groups are gases. As the molecular mass increases and adding of more carbon from pentane downward, we have liquid, and from 10 we have solid. So the first 4 group of the alkane group are gases. So the first 4 members of alkanes are gases at room temperature. The carbon atom in all the alkane can be assumed to be sp3 hybridized. And taking methane as an example, the alkane has bond angle such as an example, methane has bond angle of 109 degree, and as we can see here, it has the sp3 hybridized. So it consists of 109.5 degree or 109 degree 28 prime. So, and the alkanes consist of sp3 hybridized. Alkane has tetrahedral shape and it has a sigma bond. Briefly, we are going to discuss hybridization of hydrocarbon. Hybridization of of carbon of alkane and alkyne. Alkane contain sp3 hybridized, alkyne contain sp2, and alkane contain sp. Alkyne contain sp and alkene contain sp2. Carbon at the ground state consists of 1s, 2s, 2px, 2py, and 2px orbital. And in the orbital, 1s contain spin or 2 spin of electron, and 2s contain 2 spin of electron, and the 2px and 2py orbitals are also occupied, because carbon has 6 electron. So this is the orbital is occupied at ground state. At the excited state, electron tends to go under excitation, and one of the electron from the 2p orbital will tend to occupy the 2pz unoccupied orbital, which will make the orbital to blend to have, and which is responsible for our sp3. The 3 orbital from the p is the one responsible for 3, sp3. So sp3 hybridized. So this orbital means s and p orbital mixed together, and we have sp3, which makes this orbital ready to pair an incoming electron from any other atom that is ready to bond. So in this aspect, we are only discussing sp3 because we are discussing alkanes. So when we reach alkanes and alkyne, we might discuss other hybridization. I think which is clear. Structure of alkanes. We have methane, which consists of 1 carbon and 4 hydrogen. We have ethane, that consists of 2 carbon and 6 hydrogen. We have propane, that consists of 3 carbon and 8 hydrogen. We have N-butane, which is N-butane means normal butane, a butane of a straight chain, which contain of 4 carbon and 10 hydrogen atom. And we have the isobutane. Isobutane is a branch form of butane. It also consists of 4 carbon and 10 hydrogen, but in a branch form, that is isobutane. So you can see here it is equally symmetrical. So we have isobutane here. The structure of ethane and propane are straightforward because there is only one way to join the carbon atom in this molecule. Butane, however, has 2 possible bonding schemes, resulting in different compounds called the N-butane, which N stands for normal, and isobutane. The N-butane is a straight chain alkane because the carbon atoms are joined in continuous chain. In a branch chain alkane like isobutane, 1 or more carbon atoms are bonded to a non-terminal carbon atom. Isomers that differ in the order in which the atoms are connected are called structural isomers. So isomerism. Isomerism is the existence of molecules that have the same number of the same kind of atom, and hence the same formula, but differ in chemical and physical properties. Isomers that is different in the way or order in which the atoms are connected are called structural isomer. In the nutshell, isomerism is the existence of molecules in different molecular formula, but so in a nutshell, isomerism is the existence of molecules in the same molecular formula but differ in chemical and physical properties. So in the Alkane series has the number of carbon, as the number of carbon atom increases, the number of structural isomer also increases. Isomer increase rapidly. For example, carbon C4H10, which is butane, has 2 isomers, and C10H22 has 75 isomers, and C30H64 has over 4 million possible isomers. Obviously, most of these isomers do not exist in nature, nor have they been synthesized. Nevertheless, the number help to explain why carbon is found in so many more compounds than any other elements in real life. So this will end this video. In our next class, we are going to discuss the isomerism of alkanes and possible examples of isomerism of alkanes.